right, welcome to my calculus videos. We have a little bonus video here. Talking about anti-differentiation. This is just basically some properties of indefinite integrals. Thought we'd put them all together. So got a little scan from the book here. And a couple things worth knowing, maybe jotting down on a page so you don't have to keep looking them up. First off, what do I do if I have a constant inside an integral? Well, when I do, I can just pull it out. And this is, fairly obvious. Integral's the area. If I multiply the function by 2, well, then the area gets twice as big because every rectangle gets twice as tall. What do I do if I'm adding or subtracting two functions? Well, I can just separate them out and say, find the one, find the other, add or subtract those. Power formula, I will say I'm not a big fan of the way that's written. What I find to be an awful lot easier is to write this as 1 over n plus 1 times u to the n plus 1. Just because I prefer constants to be out front, I find it just makes life easier. And notice that this is not true when n is -1, because otherwise that would be 1 over 0. But then that takes us to n equals -1, the special case right next to this, which is that the integral of u to the -1 is natural log. As we talked in the first video, don't forget that absolute value, because this is not true. The area underneath 1 over u, if I consider 1 over u to be a function that looks like this, this area is natural log, but you just have to be a little bit careful, because if I'm over here, well, the natural log of this wouldn't make any sense because natural log isn't defined over there. All right, trig formulas, just quick. Derivative of sine is cosine, and therefore antiderivative of cosine is sine. Same thing with sine. Secant squared, derivative of tangent is cosecant squared, derivative of cotangent is negative cosecant squared, so we need a negative on the antiderivative. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent, so again, we need a negative on there. Notice again, these are all just the opposites. If you know the derivative of a function, then you know the antiderivative of that derivative. And so it's just a good habit to jot these down, have a table, function derivative, and then you can just look at it backwards. And as you use them, I don't see the point of committing dozens and dozens of functions to memory, but as you use them, it'll get to the point where, oh yeah, I know that one, I've used it enough. So again, e to the u, the derivative is itself, so therefore the antiderivative is itself. We've got a compensating function. Remember, derivative of a to the u is natural log of a times itself, which means I need a 1 over natural log of a to compensate. Video 2, we're going to talk about why this is true. Something worth adding to your notes, but we'll talk about. And I take that back. We're not going to talk about why it's true. We're going to prove that it's true. If I don't remember for sure whether we will get back to how to find that derivative. So I would recommend that you put that one into your notes as a, hey, look, there's another antiderivative that you should know. And then, of course, hopefully you remember that log base a of u, the change of base formula says that's equal to log some base, hang on, let me change colors here. Log base a of u is equal to log base b of u over log base b of a. Base b, if I choose e, log base e of u over log base e of a, but log base e is natural log. So we just have this little thing where we're just using the change of base formula to turn this into a natural log problem. Since natural log of a is a constant, we can pull this out front, and then it's just the integral of natural log of u times 1 over natural log of a. Again, the reason I like the constants to be out front just makes life, in my opinion, easier. All right, so there are some just refreshers on various formulas. Again, what's the big takeaway here? The big takeaway needs to be that the last 2 minutes of this video were horrendous. I will probably chop it out. And shall I try a third time? You won't know because you're not seeing all the chopped out bits. But let's try this. Derivative, integral. How about that? All right. Thanks for watching.